Yes, welcome to our channel Chandrasani Classes. Now we are taking important questions on properties of integrals. This is a very important part. We can have one question of 4 marks or one question of 6 marks in board exams. Now we are writing properties. First property 0 to a to b fx dx will be equal to a to b ft dt equal to a to b fz dz. If we change the variable, limits are same, there will be no effect. Number 2, a to b fx dx will be minus b to a fx dx. It means if we interchange the limits, sign will be reversed of the integral. Third property, a to b fx dx will be equal to a to c fx dx plus c to b fx dx, where c lies between a and b. Let us say this example. This is a, this is b, and c is a point. A to c and b. This area plus this area. We can split the limits a to c, c to b. This plus this. Fourth property, 0 to a fx dx equal to 0 to a f a minus x dx. This is very important property. It is used many times. Fifth property, minus a to a fx dx will be equal to 2 times 0 to a fx dx if fx is an even function, equal to 0 if fx is an odd function, Sixth property, 0 to 2a fx dx will be equal to 2 times 0 to a fx dx if f to a minus x equal to fx. All this will be 0 if f to a minus x equal to minus fx. Last property, seventh, a to b fx dx equal to a to b f a plus b minus x dx. Here these are 7 properties. We are to use these properties in solving integrals. I am again repeating. In first property, a to b fx dx ft dt fz dz. It means on changing variables, value of the integral will be same. Second, a to b fx dx minus b to a fx dx. If we interchange the limits, sign will be reversed. Third, a to b fx dx equal to a to c and c to b if c is a point lying between a and b. Fourth property, 0 to a fx dx equal to 0 to a, in place of x put a minus x here. Fifth property, minus a to a fx dx equal to 2 times 0 to a fx dx if fx is an even function, and its value will be 0 if fx is an odd function. Sixth property, 0 to 2a fx dx equal to 2 times 0 to a fx dx if f2a minus x equal to fx, and its value will be 0 if f2a minus x equal to minus fx. Seventh, a to b fx dx equal to a to b f a plus b minus x. The fourth property and this these are same, this plus this. Similarly, a plus b minus x. Now, for if a f minus x equal to minus fx, then fx is an odd function. Example, if fx equal to sine of x, then f minus x will be sine of minus x, that is minus sine x, that is minus fx. Therefore, this is an odd function. Second, if f minus x equal to fx, then fx is an even function. Let us say one example. If fx equal to cos of x, then f minus x equal to cos of minus x, and this is equal to cos x, f minus x. Therefore, f minus x equal to fx. It means this is an even function. These two properties will be here. If limits are 0 to 2a, this will be 2 times 0 to a fx, if fx is an even function. Otherwise, its value will be 0 if fx is an odd function. Yeah, very short, 2 times. Now we are taking some questions based on these theorems. Yes, we are taking this question. 0 to pi x tan x dx divided by sec x plus tan x. Yes, applying fourth property. 0 to a fx dx equal to 0 to a f a minus x. Fourth property. Yes, in place of x, put pi minus x, pi minus x, pi minus x. Yes, we know that tan pi minus x minus tan x. Sec pi minus x minus sec x. This is also minus tan x. Minus take out, minus minus cancel. Therefore, we get pi minus x into tan x dx divided by sec x plus tan x. Suppose this as a and this as b. Add them, a plus b. We get I plus I, 2i equal to, taking tan x out, we have there x plus pi minus x tan x divided by the sec x plus tan x. Yes, x will be cancelled. Take pi out. Our integral will be 2i equal to 0 to pi tan x divided by sec x plus tan x. Yes, convert tan x into sine over cos, sec x 1 over cos, tan x sine over cos. Taking LCM, 1 plus sine x divided by cos x. Cos x will be cancelled. We get sine x over 1 plus sine x. Yes, add 1 and subtract the same 1 and separate them. 1 plus sine x over 1 plus sine x minus 1 over 1 plus sine x. This will be cancelled and we get here 1. 1 minus multiply by 1 minus sine x and divide by the same number. We get 1 minus sine x, a plus b into a minus b, that is 1 minus sine square x. Yes, 2i equal to pi, therefore 2i equal to pi, 0 to pi 1 minus sine x, 1 minus sine square equal to cos square x. and divide this over this sec square x, this over this sec x into tan x. Yes, 2i equal to pi, 0 to pi, 1 minus sec square x minus sec x tan x. Now put the limits, 0 to integrate sec x, its integral tan x, its integral sec x. Yes, put the limit, upper limit pi, pi minus tan pi plus sec pi. Putting 0, lower limit 0, tan 0 and sec 0. We know that tan pi equal to 0, sec pi equal to minus 1, minus this is 0, this is 0, minus sec 0, and sec 0 equal to 1, pi minus 1 and minus 1, pi minus 2 into pi, therefore 2i equal to pi, therefore I will be pi into pi by pi into pi minus 2 divided by 2. Now we take next question. Yes, take second question. Integrate 0 to pi x tan x divided by sec x into cos x. Yes, 0 to pi x sin x divided by cos x dx. Similarly, 4 sec x 1 over cos x into cos x 1 over sin x. Yes, cos x will be cancelled. This will be 0 to pi x sin x into sin x sin square x dx. Let us suppose this is a. Apply the property 0 to a fx dx equal to 0 to a f a minus x dx. I equal to 0 to pi. For this put pi minus x and sin square pi minus x dx. 0 to pi minus x. We know that sin pi minus x equal to sin x, therefore its square will be sin square x dx. Suppose this as b. Yes, and a plus b. I plus I, 2i equal to 0 to pi x plus pi minus x, and sin square x take out, sin square x dx. This will be cancelled. Therefore 2i equal to 0 to pi take out, sin square x dx. Now 2i equal to pi, 0 to pi 4 sin square x, 4 sin square, put 1 minus cos 2x divided by 2 dx. 2i equal to pi by 2, 0 to pi 1 minus cos 2x divided by, yes, 2i equal to pi by 2, integrate x, its integral will be sin 2x divided by 2 and limit 0 to pi. 2i equal to pi by 2 equal to pi by 2, put upper limit sin x minus sin 2 pi divided by 2 minus 0 and minus sin 0 0 divided by 2. 2i will be equal to pi by 2 pi sin pi 0 and this is 0 and this is 0. Therefore 2i equal to pi by 2 into pi. Therefore 2i equal to pi square by 2 or I equal to pi square by 4. This is your answer. Yes. I am repeating again. We are given this question. Integrate 0 to pi x tan x sec x cos x. Convert tan x sin over cos x 4 sec x 1 over cos x 4 cosec x 1 over cos x. Cos x will be cancelled and this will go up and we have there x sin square x dx. Now by applying this property 0 to pi in place of x put pi minus x, also pi minus x. Pi minus x, we know that sin pi minus x to sin x, therefore sin square x. Yes, this is b, this is a, add them I plus I 2i 0 to pi. Here x sin square x common, x plus pi minus x, x will be cancelled. We get pi sin square x dx. 2i equal to pi 0 to pi. Yes. For sin square x, put 1 minus cos 2x divided by 2. Yes, take out pi by 2 and its integral 1 minus cos 2x. Integrate this. Its integral will be x. Its integral will be sin 2x divided by 2. Upper limit minus lower. Put upper limit pi minus sin 2 pi divided by 2 minus 0. This is 0. This is 0. This is 0. Therefore, we get pi by 2 into pi, that is pi square by 2. Therefore 2i equal to pi square by 2. Therefore I equal to pi square by 4. We take next question. We take this question. Question number 3. Integrate 0 to pi x sin x divided by 1 plus cos square x dx. Yes, applying the same. This has been asked in All India 2013, 2012 and in Delhi board 2009 compartment 2008. Yes, I equal to applying the same property 0 to pi minus x into sine of pi minus x 1 plus cos pi minus x whole square dx. I equal to 0 to pi minus x sin pi minus x, that is sine of x 1 plus cos pi minus x minus cos x, its square will be same 1 plus cos square x dx. Suppose this as b, this as a. Add them, add a and b. 2i will be equal to 0 to pi sin x common, therefore x plus pi minus x into sin x divided by 1 plus cos square x dx. Yes, cancelled. Therefore 2i equal to pi 0 to pi sin x dx divided by 1 plus cos square x. Yes, put it, let cos x equal to t. Therefore minus sin x dx will be equal to dt, or this is minus dt. Therefore 2i will be equal to pi for sin x dx minus dt divided by 1 plus t square. Put the limit, if x equal to 0, that is 1, and pi cos pi minus 1. Yes, 2i equal to pi, take out negative, we have there 1 minus 1 and 1 by 1 plus t square dt. 2i equal to minus pi, its integral will be tan inverse t, limit 1 to minus 1. Yes, interchange the limit. 2i will be equal to pi minus pi tan inverse minus 1 and minus tan inverse 1. 2i equal to minus pi. Its integral will be minus pi by 4, its limit, and its value will be pi by 4. Yes, minus pi into minus pi by 2, the minus plus pi square by 2. Therefore, I equal to pi square by 4. Yes, this is your question. Apply the theorem, fourth property. In place of x, replace pi minus x, pi minus x, pi minus x. Pi minus x, sin pi minus x equal to sin x. Cos pi minus x minus cos x square will be plus cos square. This is a, this is b, add them. A plus b, I plus I, 2i, and this is common. X plus pi minus x, x will be cancelled. We get sin x dx over 1 plus cos square x, 2i equal to pi, 0 to pi. Take cos x equal to t, then sin x dx will be minus dt. Therefore, this will be minus dt 1 plus t square. Take negative out. Therefore, 1 minus 1, 1 over 1 plus t square dt. And its integral is tan inverse t. Put the limit, upper, lower limit, upper limit. Yes, minus pi, tan inverse minus 1, minus tan inverse 1. This is minus pi by 4, this is pi by 4. Minus pi by 2, minus minus plus pi square by 2. Therefore, I equal to pi square by 4. Thanks. Yes, share our channel, like also and comment. It will be so kind of you. Thanks.